Congratulations, winners. Now, last but not the least, still very important session and very important every life and to stay safe. Now we have an influencing speaker, Mr. Srinivas V, Director of Indian Plumbing Skill Council Synergy. Before I hand over the mic, I have great pleasure in introducing to this gathering. Mr. Srinivas is a Director of Indian Plumbing Skill Council Synergy Infra, postgraduate in Electrical Engineering, 38 years of experience in designing MEP services, worked for Department of Space, Government of India from 1985 to 1995 in planning of various ground services for space programs like PSLV, GSLV, etc. Established Synergy Infra Consultants Private Limited in year 1996 and worked on various projects like healthcare, residential, commercial, IT, retail, etc. Besides defense projects of national importance, healthcare facility design professional certified by ASHRAE, chartered engineer, chartered energy auditor, accredited professional IGBC, master trainer, energy conservation building code of India, member and professional organization like IEE, ASHRAE, ISHRAE, ISLE, FSAI, IIP, IPA, member of Institution of Fire Engineers UK, recognized by Engineering Council of UK, past chair of IPA Hyderabad chapter, past president of FSA Hyderabad chapter, director Indian Plumbing Skill Council, made presentations at various forums in India and abroad. I welcome you, sir.
Thank you very much. It's a bit embarrassing for me to, Anyway, thank you very much. And first of all, I would like to congratulate the organizers, CAHO and ISHRAE, for doing such a wonderful event. And naturally, like everybody, after the lunch, I thought I could take a nap. But the voice of Mr. Prashant Desai has not made me to have a nap. And then, of course, with this kind of game, whatever they have done, I think it's the first time I am experiencing such a quiz. It's a very wonderful event, I would say. I enjoyed. Even though I'm not supposed to participate, I don't know about that. But out of interest, I just wanted to participate. That's the thing. Okay, now, morning onwards, we have been hearing a lot of talks about the kind of negligence with respect to the spaces given for air conditioning or otherwise, improper planning by some of the architects or doctors or whatever it is. But I'll tell you the least important thing that is given is basically with respect to fire safety. And only thanks to the fire departments and then NBC 2016, at least there is some lot of awareness now today it's developed. And because it is insisted by the fire department, at least some of the hospitals have been started looking at the fire and life safety issues. So let me just, the subject, whatever, today, sorry, we have any, how do I move it? Any slide changer or it's not operating? It's not moving here. This one? Even this is not moving actually. No, it's there on this one, right? One of the, many of the cases, even whenever we practice, a lot of doctors come and say, nothing is going to happen to my hospital. Don't worry about fire and life safety issues. And in one of the hospitals in Hyderabad, which we were designing a 300-bed hospital, somewhere in 2008, 2009, one of the doctors said, forget about it. I don't have 80 lakhs to spend on fire systems. So I have 8 lakhs, do whatever you want. Then I said, probably you can remove me as a consultant and you will save another 2 lakhs. And then, at least spend that money on the hospital. And later, when the incident took place, at the AMRI hospital, which was one of the worst incidents that happened in a hospital, then that day night at 10 o'clock, he called me, do you think, Srinivas, is our hospital safe or do we need to do something? Till that time, they were not, thinking that anything can be done to the doctors or to the hospitals. Only the directors of that hospital were jailed. Then they started realizing the importance of fire and life safety. Unless we have this kind of untoward incident, incidents, I think people will not come to know about it. Or otherwise, there has to be some kind of regulations. Morning also, we are talking about AHU room spaces and so many things. I think NABH should come forward and try to make these things legally binding by the hospitals. I think then only people will start looking at it. What kind of air conditioners or what kind of AHUs, what should be. Now today we have certain guidelines with respect to the space and the number of air changes and fresh air changes and other things. And if you look at the hospitals, you look at, any kind of occupancy, hospitals has got a very, very high importance with respect to the fire and life safety, because, they have physically impaired people who cannot move in case of any kind of eventuality. You need to make sure that, and another thing is sleeping risk. In the rooms, there are a lot of people who will be sleeping, and they may be under sedation. I'll tell you, one of the hospital fire accidents that happened at Warangal sometime in 10 years back, there was only one casualty in a 200-bed hospital. The person who was on the operation theater table. So all the doctors and nurses ran out of the hospital when there was an issue happened. Basically the fire started from the operation theater itself, and everybody ran away from the hospital. But unfortunately, the person who was under sedation, he could not move on his own. So this is one of the major issues. And also, morning, Mr. Gautam was talking about oxygen-rich environment. I'll show you a video how a fire can take place in an ICU. We have a live video where we have taken actually. I don't know, I don't say luckily, but I should say unluckily, when we were there, this incident happened. And when a nurse was trying to plug out something, then suddenly there was a spark, and then there was a big fire, it happened. So this basically, if the oxygen level, if it goes beyond 23.5%, the fire is, immediately it's going to ignite. You have, everybody knows that there are the three legs of, a triangle, fire triangle, basically. The ignition, whatever it is required, and then the fuel, it will be there everywhere, and oxygen, that is also there. And here in these cases, the oxygen content is much higher than the normal level. When we have done some audits with respect to fire safety, especially in ICUs and OTs, the oxygen levels are almost around 23.5%. We have all, recorded, documented evidence for all these things. So we have to be very, very careful whenever there is an incident for this. So let us try to understand whatever NBC and other things says. And this presentation is picked up from the book, whatever has been released today. And I think that is going to be a very good resource. Even, if you look at the ASHRAE Healthcare Handbook, whatever is published in 2013, it doesn't have much on fire and life safety. But our book has got a wonderful chapter, I would say. It's not, a lot of people. No, not only me, I'm sure. A lot of people have contributed to that. It's a very good, this one. You see, this is the worst incident. That's what I was talking about. 2011, the government of West Bengal has started making a smoke management system as a mandatory requirement in all hospitals after this incident. Of course, it's not a requirement as on today in the National Building Code of India. And if you look at the hospitals, we have, many equipments, especially high-powered equipments like UPS systems, CTs, MRIs, and other things. We have a lot of other, incidental issues related to all this kind of equipment, that is harmonics and other things, which may create some kind of overloading of the cables and transformers, which may again result in case of, in the fire accidents and other things. And also chemical hazards, there will be a number of, like chemicals and anesthetics materials or otherwise other disinfection agents, which is the reason for many of the COVID hospital fire incidents that have happened during the COVID. There were around 27 hospitals which went under fire, actually. There were a number of casualties. In Vijayawada, we could see one of the hospital, which we have studied later, there were around 12 or 13 people died in that particular incident, which is a makeshift arrangement, a hotel converted into a hospital, basically. And what it causes, these kind of issues is basically because of the oxygen-rich and disinfection agents, and there will be a lot of medical gases which will be used. And oxygen, definitely, it is very good and is required for us, but in abundant quantity, more than the required quantity, it is going to create a problem. Especially even, in ISRO, we used to handle liquid oxygen or liquid hydrogen tankers, which are highly inflammable kind of material. And then other sources of hazards, we have, you name anything, it will be there in the hospital. That is the problem. You look at, I mean, any kind of other occupancy, there is no problem. We have laundries, we have air conditioning systems, kitchens and canteens, general stores. There were a couple of, in fact, even today, I don't know, most of the hospitals, they rely on this paper filing systems and other things because of some regulatory requirements. And those areas, they should not have any kind of power supply. But unfortunately, the kind of sparks and other things, they can create an immediate fire incident. And then I'll show you some of these things. It's not only during the design, but even during the occupancy stage, we find lot of issues. I'll show you some of the photographs. More than all these things, lack of awareness. I would say people have not realized. We realize only whenever there is an incident that, okay, we have to be careful about it. But after some time, again, it is forgotten. That is the problem with us. And you can see this is one of the hospital which we have found out in some of the cases where we have a lot of storage. I would say whichever the spare areas, they try to dump all the material, and whichever could be occupied, they occupy for the purpose of patients and other things. You can see some of these spaces, the corridors, which are completely closed for seating and other things, OPD areas, and people cannot move in case of any kind of eventuality. These are all the hospital fires that happened. I mean, this is taken from one of the books, and from between 2004 to 2010, out of, the number of almost around 60 accidents that happened across the globe, most of the things are related to split air conditioners or DX air conditioners, or otherwise incubators in the hospitals. Incubators is another major issue because it uses a lot of power, and every incubator is supposed to have a residual current circuit breaker. We'll talk about, some of these electrical safety aspects as also part of this, but otherwise you can see all these things, either incubator or otherwise space heater, otherwise air conditioner. And as Mr. Gautam was talking about in the morning, most of the areas, this kind of room air conditioners are not allowed actually. But the unfortunate problem is most of the hospitals, smaller hospitals, they don't go for chilled water systems, take it from me, because they feel it is very high. They don't mind spending, they don't look at life cycle costs and other things. They want to make sure that the facility is operational. One of the doctors was telling me, I don't need even split air conditioners, Srinivas, I can make a surgery outside. I said, that is impossible. I mean, nobody can think of it. He's a cardiothoracic surgeon who was talking, but that was awareness in those days. It was in 2000 what I was talking about. But today, he built number of hospitals, but definitely they realized the importance of this. And one of the incidents, what I picked up, I told you, is only from that. So you can see here, there are a number of monitors, number of systems and other things, along with the air conditioner. Even a capacitor failure in an air conditioner, it will create probably a small spark and results in a major fire. This is all the medical gases and other things which have been used. And I think many of you may be aware, it's not, the fire that causes generally a problem, but it is the smoke. Most of the deaths happen only due to smoke, that is asphyxiation, lack of oxygen, whenever there is a fire incident. And 57% of the people, they are all facts from NFPA which have been picked up, they are not in the room of fire origin. In fact, NFPA has revised their Fire and Life Safety Code 1/1 in the year 1980 after the MGM Grand Fire that has taken place. Before that, there were no fire doors, there were no sprinklers in many of the areas. But after that incident where number of people died, and especially people who are not in the location of fire origin, but they were all in 18th floor or 20th floor. That is where they died, but the actual incident happened in the kitchen in the ground floor actually. And so that is why there are a lot of, the compartmentation and then life safety issues have started playing a major role. And visibility is a major problem. So you talk about tenable conditions whenever there is a fire. That is basically with respect to visibility, toxicity, and the temperature. These are the three things which are detrimental for any kind of person. And it will not allow us to evacuate even the people. So if you're able to maintain these three things, definitely the facility will become at least we will be able to take care of the patients. You cannot expect a hospital to be evacuated in any case of fire. We can only look at shifting people from one compartment to the other compartment. So this is what NFPA calls it as defend in place. We cannot look at, some help from outside, where a fire engine will come or an evacuation can come or help can come from outside. The system, whatever the building that is planned should be designed in such a way that people, whenever there is a fire, we should try to make sure that the smoke is taken out, and that should be put under negative pressure, and rest of the areas, whichever the egress areas and the protected areas, should be under positive pressure, so that the people can be safe. And these are the 5 elements what generally we look at it, the fire prevention, which is the most important thing. The NFPA also gives, if you look at the safety index, NFPA, whatever they have given, out of 100%, 80% is given only for the planning of the hospital, not for any of the active systems. In fact, the weightage given for sprinklers is only 8%. Fire alarm systems is only 5%. Sprinkler, which we treat it as one of the first line of defense, because not the fire alarm system, they can only give an alarm, but whereas a sprinkler can probably protect the place. So even for that, the value, whatever the weightage is given, only 8%. So what is that? It's basically evacuation, the compartmentation, how the passive architecture and passive systems, how they are going to be done. That is what will have a very significant role. And also the systems, whatever we design, like electrical systems or your air handling systems, how they are going to be compartment-wise, how they are going to be segregated, and make sure that every compartment is maintaining its own integrity, so that there cannot be any smoke going from one room to the other room. I don't have that video because last time, 2007, ACREHEALTH itself, I remember we have presented that. So at that time, we've shown one of the video by NFPA, where if there is a room of 20 feet by 20 feet by 10 feet, and if there is a small pencil hole from the other room, and if there is a fire in the other room, this particular room will get completely filled with smoke, where you cannot see your stretched hand within 3 minutes, 40 seconds. So that is how it will become, filled up with this smoke. So that is why compartmentation plays a very vital role. Make sure that there are any kind of openings in that case. And evacuation, fire detection, of course, and the suppression and fighting is the last thing. With respect to, because most of the fire incidents, people say it is due to electrical short circuits. That's how, being an electrical engineer, I started looking at why we are causing so much of trouble, why we cannot, try to mitigate these kind of issues. The new IS 17512, I'm sure most of you must have seen. This was released in 2018 during the COVID time. And this particular thing is basically electrical systems for the healthcare facilities. And most of our code also basically drawn from the extract from this particular thing. It has been, the entire hospitals have been defined, divided into 3 different groups, group 0, group 1, or group 2, where in case of group 0, there will not be any kind of electrical contact with, for any kind of patients, for any, so that is something like, massage rooms, or in kind of, some physical activity rooms or something like that. But otherwise, in group 1 areas where there is a possibility of either externally or invasively, where the people can get, electrical equipment can get in contact with the people. And group 2, that is going to happen. That is in most of the operation theaters and other things. 2 things, this is the bifurcation what they have given. You can look at the massage rooms, and then some of the bedrooms and all other things are all in group 1, whereas all the critical care areas like ICUs and then operation theaters and other things are in group 2. So most of the things, I would say only 2 parameters which we need to make sure in any kind of hospital to make it safe. The first thing is, make sure that the complete earthing system, an equipotential bonding, because there could be a lot of shock hazards also. In fact, when we talk to a lot of medical equipment suppliers, I talk with MRI or CT or X-ray or any kind of UPS guys, everybody will come and say, I need 2 separate earthings for this, 2 separate earthing for this. And they go and threaten the doctors, sir, this equipment costs around 4 crores MRI, but your consultant is rejecting to give 2 earth pits. It is not the question of giving 2 earths separately for that, but none of the codes, either Indian or international, will not allow it. We need to maintain entire earth grid at 1 potential, 1 building, 1 earth. So please understand that everything, even the IS 17512 or National Electrical Code of India or IS 3043 related to earthing, everything talks about it. We need to have, even if you take IEEE Green Book or otherwise the IEEE Standard 80 for substations, anywhere, wherever it is, 1 building should be 1 earth. If you want to create different earth pits, create, no problem. But the thing is, you have to make sure that they're all integrated and brought to equipotential. Not only this, any kind of metallic systems like your air conditioning pipelines, water pipelines, fire lines, or any kind of other mechanical, any kind of metal things which are there, even operation theater doors, They all have to be connected with an equipotential bonding conductor. Then we can make sure that there are no interferences, there will not be any kind of safety hazards. This is the first principle. The second thing is any kind of leakages. This is the major issue, Provide RCCBs, residual current circuit breakers. That is what the code says. Any kind of facility, you provide residual current circuit breakers with 30 milliamps sensitivity. Most of the faults can be isolated. So 30 milliamps beyond 30 milliseconds is definitely going to cause a death of a person. Whereas, 100 milliamperes of leakage current can cause a fire accident. This is what NFPA somewhere they referred about it. So that means if you provide a 30 milliamps RCCB for most of the areas, then there will not be any issue of any kind of leakage. Anyway, you will have overload protection, short circuit protection, and all the other things. The one more thing is where you need to have continuity of power. Like operation theaters, and also NFPA 99, that is basically for healthcare facilities. They also say any kind of wet areas, even ICUs for that matter, where you need to have continuity of power, where we cannot have RCCB because RCCB will trip the supply. It will isolate the power supply. So that is not allowed again. So in such cases, go for isolated power supply systems. So where you need to have an isolated power supply system that keeps monitoring the insulation resistance of the entire electrical system that is connected to the IPS through an electronic monitoring system. And if the leakage currents are beyond 5 milliamperes, it start giving an alert to a nurse station, or through BMS, wherever it is required, we can connect it. But we don't find in many of the hospitals, because each isolated power supply system for an operation theater, operation theater needs around 8 to 10 kV of power. And so that costs around 3 lakhs. So for each operation theater, it costs 3 lakhs, and doctors say, no, forget about it. We don't want it. But what is the safety of the people? This is how it will happen. Whatever had happened in Warangal Hospital, whatever I referred, the similar kind of situations can happen. But the thing is, if you provide it, I think the system can be taken care and there will not be any issues with that. And except for X-rays and other things where there could be some kind of leakages and any equipment beyond 5 kVA, I think rest of all the things need to have either isolated power supply or otherwise with RCCBs. And I talked about this is all about the equipotential bonding conductors and other things. And this is the sketch which we also given in our book, and as well as from the National Electrical Code of India and IS 17512, where all the equipment, either you take even your communication equipment or server racks or whatever it is, everything, if you want to maintain a separate earth, you maintain separate earth up to the main earthing bar. You can have one main earth bar for the electrical system, one main earth bar for the communication systems, but both have to be integrated again when the building is concerned. So this is also part of that. And then we need to have emergency power supply systems and other things, because that is very, very critical in case of a hospital. And there is also a class of, when I have shown that particular table of zone 0, zone 1, zone 2, there is also another group where we need to have what kind of break is allowed in which kind of areas. So most of the operation theaters and ICCUs, we need to have no break systems. And some of the areas we can allow up to 0.5 seconds to 15 seconds of break. That means you can have a DG backup. And some of the other areas, it can go for a long-term, probably a break, like rooms and other things. And also the electrical panels and other things. This is as per NBC. We need to have, the main electrical panel, emergency supply panel, and lifts panel, because these are the life-saving things for any kind of, hospital. Because not only hospital, for any kind of facility for that matter. This recommendation is for any kind of thing. You need to have an inert-based gas flooding system, or otherwise a CO2 system. CO2, there is a problem. It may leave a residue on all the equipment, Whereas an inert gas system, it will get evaporated. So there are two different type of systems where the gas, this can sense the any kind of sparks or otherwise any kind of fires within the panel, and immediately it can release the gas. Or otherwise there could be a sensing cable and then gas. It's like a pre-action system, the second one. And transformers and other things, I'm sure you are all aware, we cannot have any oil-cooled transformers within the building. They all have to be outside. If it is to be within the building, it has to be a dry-type transformer. And it has to be separately compartmented. Wherever electrical rooms are there, they need to be compartmented with 2-hour fire-rated valves. And they need to have a separate mechanical ventilation systems through fire dampers for both supply and return. Otherwise, you can't maintain the inside conditions, whatever required within the electrical rooms or any kind of service rooms. That is what the NBC recommends. And even dry type transformers have to be separately compartmented. This is what the NBC says, but generally, many cases it is not done because there is no oil and there is no hazard. And the DG rooms also have to be separately compartmented. And major issue, I'll tell you another thing related to hospitals, is the UPS systems. You will have huge UPS systems. I'll tell you, MRI guy will say, I need a 120 kVA UPS. If you look at 128 slice or 64 slice MRI, they will say, I need a 120 kVA or 160 kVA UPS. CT will have around 80 kVA to 100 kVA UPS. And they try to keep this UPS also in the control room where next to the equipment itself. Batteries are one of the major, again, source of fire. There are many cases where batteries have exploded. At least I have seen 4 hospitals, including Columbia Hospital fire in Bangalore, and also 4 another hospital in Hyderabad, and again another 2 IT parks, where there was a major fire that was caused by the blasting of batteries, explosion of batteries. So batteries should never be within those kind of spaces. They have to be compartmented separately. It is better that you take out all the batteries, either it's lead acid or NiCad or lithium ion or whatever the kind of batteries. Every battery is got its own disadvantages, and there could be a kind of explosion that can happen. And so we need to have a separate ventilation systems and with fire dampers. And also air handling units, you are supposed to make every compartment with a separate air handling system, or otherwise if you have to use a common air handling unit, make sure that there are fire dampers within the ducts. And any kind of metal ducting systems, they have to withstand at least minimum 30 minutes of fire rating. This is what is one of the recommendations. And also wherever there is a fire separation wall, where ducts or other things enter the vertical shafts, all these things have to be completely sealed off. Okay, this is how it is supposed to be done. You can also refer in the book whatever has been issued. And another thing is glazing. The most of the hospitals I've seen, they want to seal off all the windows and other things, because infiltration and exfiltration of air causes a lot of infection issues also. That is one point. And second thing is loss of energy. Because of these things, they would like to make sure that they are completely sealed off. And the problem is, whenever there is a fire, how the smoke will come out of that place, how smoke can be exhausted out. So the most important, either make sure that there are openable windows or break open kind of windows, and there are certain guidelines given by the code. Every 10 meters you need to have an opening of 1 meter by 0.5 meters or whatever it is, size, 1 meter by 1 meter. So that kind of sizes we need to create, or otherwise provide a smoke management system for those areas. So NFPA also recommends smoke shafts and other things for these kind of buildings, where we can have these smoke management systems with that. And so there has to be 1.2 meters at a height to 1.5 meter height. We need to have 1 meter by 1 meter openings, and they all should be labeled. Another major problem is kitchens. In major hospitals, they will have, inside the hospital itself, they'll have food preparation and other things. And including MGM Grand Fire, many of the fires have started from the kitchens, because this is where there is a lot of abuse, I would say. I mean, because the ducts are not cleaned, and there will be a lot of oils and other things which will get and stuck to the ducts. And if they are not properly cleaned, they become a major source of fire. So that's why you need to have thermal detectors, heat detectors in these areas, and they have to be, in case of fire, they have to be automatically, AHUs should be switched off. And also the food areas and dining areas have to be completely separated out with a fire-rated compartments, which is again an issue. And also LPG leak detectors and sprinklers, maybe of a higher rating up to 141 degrees centigrade, they need to be provided. I'll tell you one of the other things what we have noticed in many of the hospitals is this bed-headed panels. We see that, medical gases and electrical sockets both are run through the same bed-head panel. So this is what I would like to show you this video here. Hope I will be able to open it. Just see for a few seconds. See that fire which is, this is an ICU, basically it's a ward. A lot of people, including our team, was there when they were doing something. So somehow they have taken this video, but I'll tell you, they're able to extinguish immediately. But suppose, there are no people. People will get panicky with this kind of, this is not the first incident. We have seen this kind of incidents, at least 2 or 3 incidents in ICUs especially, Not in operation theaters, but definitely in ICUs we have seen. The problem is most of these bedded panels, as per IS 17512 or electrical code, it should have a separation of 200 mm. But entire bedded panel itself is 200 mm, where we'll have both gas lines and electrical sockets. So otherwise, if you want to run, you need to have a gas-tight compartmentation between the two. Nowhere, I have not seen, at least, I talked to a lot of people, but it is not done. So we started explaining to the doctors that this is one major source of fire. We should not create this kind of problem. The problem is most of the equipment, especially like ventilators and all, the nursing staff, they try to plug in and take a plug out. So they don't even understand how to switch off and how to remove a plug. They generally plug it in and plug it out. The moment when they are plugging it out, or even when they switch it off also, there could be a small minor sparks. And with the kind of oxygen that is prevalent in these kind of areas, I think the fire is going to be instantaneous. So that is the reason this is one of the major recommendations which is not followed. That's what we see. And the electrical wiring, especially this kind of gas outlets, should not be towards any kind of exposed electrical wiring and other things. And medical gas rooms should be ventilated well with 12 air changes per hour, or otherwise better to be provided outside with complete natural ventilation. And LPG cylinders, anyway, again, we have a separate code for that, IS 6044, which need to be followed. And with respect to the life safety part of this is all about fire prevention and life safety. You need to have, for any kind of hospital, anything more than 15 meters as per NBC, you need to have a fire shaft or a fire tower, which is derived basically from BS 9999. Earlier it was not there. In NBC 2016, we got it included. And this particular thing where you need to have a staircase, a lift with a common lobby, and this is one of the major rescue areas for any kind of high-rise building. So this, we have to make sure that this particular thing is properly protected. So there was a question earlier, the staircase width has to be minimum 2 meters, and when we are working out the aggregate width of total staircases, it is worked out at 15 mm per person, whereas normal office buildings and other things, or residential buildings, it is taken 10 mm. So we have 50% extra requirement for the hospitals based on the occupancy levels. Even the occupancy, basically, there are all these guidelines which are given in the book again. 15 square meters, we generally take one occupant in a hospital, especially in OP areas. So based on that, we need to work out whatever the staircase which is required. And they also have to be within the travel distance of 30 meters. And if there is an entire building is sprinkled, you will get another 50% relaxation where we can go up to 45 meters. And then dead-end corridors, I'll show you another picture which is about the dead-end corridors. So this is what is a dead-end corridor. Generally what will happen is if people come out of this, whichever the room they come out, they should be able to go in any direction. So if they have an option to go in 2 directions, it will be always helpful. Whereas if they go in one direction, if there is no exit, they have to again come back. So that is why this particular 6 meters is only allowed in case of that. And I think the time done. I got a bell. I'll try to complete early, but I have a lot of other slides, and this is the entire book we try to capture in this particular thing, which could be probably as a training, which we were talking, Mr. Gautam and others. So anyway, even the staircase, we should have, complete width of staircase as a landing requirement. Doors should not encroach into the landing areas. And this is the pressurization. Yeah, any kind of, staircase, which is, building is less than 30 meters, the natural ventilation is allowed. But anything beyond that, we need to have cross ventilation. That means windows have to be there on 2 sides of the staircase, probably 2 opposite directions. But whereas if that is not possible, we have to pressurize the whole staircase to a pressure of around 50 pascals, when all the doors are closed. In fact, we don't have proper guideline for the pressurization system, except whenever there is all the doors are closed is what is specified in the NBC, but unfortunately all the doors will never be closed. When there is a fire, there is a door which is at the ground level which gets opened, and wherever there is an event, that door will get opened, and whenever maybe one more floor also has to be done. So different countries have got different requirements, like Singapore has got a requirement of 4 doors to be considered, whereas US they say 3 doors, Canada they say 4 doors. So we are also from ISHRE TG, a new committee is being formed to work on pressurization systems. So mostly I think that particular code will have all these things spelled out clearly. But otherwise in India we don't have any code. But this is one thing which is taken from BS 9999. So basement ventilation and other things are known to most of the people, and smoke management systems only for the closed corridors. I'll try to skip off some of these things, and fire sealants, make sure that all the shafts are completely sealed off. And this is a table which is again picked up from the same book, where we need to have what kind of fire norms and other things to be followed for a hospital of different heights, again taken from table 7 of NBC basically. And the fire alarm systems, how they have to be controlled. You know that fire alarm is also a basic requirement, but the thing is, whenever there is a fire, we need to make sure that our fire AHUs are cut off, and then same way all the exit routes are completely opened so that the evacuation take place. Yeah, that's it. Thank you very much. Hope I didn't exceed much. Thank you.
We have questions, sir.
Yeah, sure.
We're open to a couple of questions.
Diathermy is equally important from the surgeon's point of view.
Absolutely. You're right. Diathermy also is. NABH has already come out with certain guidelines on these things, whatever the fire safety requirements, and they are also asking every year whatever the audit, NABH audit is done. Now this is one of the requirements. Without that, they are not giving approval to my knowledge. In fact, they are also doing panels and other things, thermography and other things.
We need to get an NOC from the fire safety.
department, yeah.
No, we get it, but the question is that almost 100% hospital, the bed is like that only.
No, you see, the problem is there are a lot of people who tries to deviate and take approvals from the fire department. That is the issue. And also there is a problem. What we see is many of the hospitals, there will be occupancy change. First, initially it is built for
Here,
an office.
from the NABH point of view, because I have been a senior assessor, fire NOC is not important to us. The fire NOC clearly mentions that you have got this NOC subject to this provision written at the back. So we use that subject to as a checklist to see whether the hydrants are there, whether the smoke detectors are there, whether the sprinklers are there, whether the public address system is there. These are 5 or 6 components of the complete fire system. So we take that as a checklist, not the NOC.
NOC is also asked for, but at the same time, this is also done every year audit.
One question about the earthing.
Yeah.
You said everything, all the earth has to be interconnected and one single earth. With my experience, the ENMG and EEG, what they take, that is a very low voltage, this one. So the earth, if we connect it to the other earths, even a
They are
slight,
supposed to be with double insulated equipment, actually, most of
Yes.
these kind of things.
But when we
So
connect
there is
the-
no issue with that.
but when we connect it to the other earths, it affects the readings which come in the ENMG. The
But,
patterns, the what do you call, the electrical impulse is very low. So that
But
affects.
I'll tell you, sir, my experience, whatever the hospitals we have done at least around 6,000 to 7,000 beds so far delivered. And most of the hospitals, we practice this and we never had any issue.
Okay.
If we maintain completely on equipotential bonding, this is what is done in all the, we can have a look at it, whatever the hospitals we did, right from 300 beds to 1,600 bed hospitals, absolutely no issue.
Thank you. And one more thing about the fire
And
risk.
where they have not done equipotential bonding, there we had in fact interference issues and other things.
We had the other way around. We had linked single
Probably we can see why it is causing that kind of thing, and that can be addressed in my opinion. Yeah.
And one more thing about the fire risk, the most highest risk we are facing nowadays is mobile and lithium batteries being charged on mattresses in hospitals in the night.
Absolutely, I agree. Not only that, we are going to face another problem, car park areas, there are going to be a lot of EV vehicles. And this is what I addressed 15 days back in L&T in their in-house seminar.
The anti-static flooring.
Absolutely.
Anti-static flooring.
This was there in this,
Yeah,
some of
I
these
know.
things, but we
But
didn't.
do you think in manifold room also we should start having the anti-static?
Not required.
Why?
No, you see, anti-static also, it's basically a conductive flooring. With some
Yeah.
kind of resistance, ultimately it
Some
will be
resistance.
conducting.
Yeah.
Earlier, in 20 years, 25 years back, we used to provide earth strips buried in the hospital operation theaters. But now with the anti-static flooring and then having proper equipotential
It's
bonding,
2
we
hours
don't have any
fire resistant. 2 hours fire resistant.
fire resistant. Yeah.
So it gives you the time for,
But even with regular equipotential bonding and earthing, that should be good enough for the other
Manifold.
manifolds.
Oh.
The only thing is if we maintain that separation between gas lines and electrical systems, I think, it's kind of sparks. Majority of the issues in critical care areas can be addressed. And also the NEC has given, certain areas where we should not have any plug points and other things, especially in operation theaters, where within the 2.5 meter range, we are not supposed to have any permanent plugs and other things, which can leak. Yes.
One photo also you showed a small bedded panel. In that you had showed the outlet and next to that.
No, that is what I said, it's a wrong practice. That's the only reason.
But you have also said a solution that you should have a compartmentalization.
Yeah,
among
gas
the
tight
gases.
partitioning.
But how effective will that be?
It will be effective. You see, the issue
Because
is
anyhow, even in that video also we could notice that the spark is happening outside the panel, and once the spark is being touched with the oxygen coming outside the flow meter, both gets ignited.
Correct.
Not inside the panel.
Correct.
So how much
No,
effective?
even for that gas tight partition also, IS has given another criteria where your voltage and current, whatever the multiplication of that, should not be more than 10 VA or something like that. Only in such cases you can go for that. Otherwise, maintain 200 mm distance.
But in ICU scenarios, so every bed will be subjected to a clearance of 5 feet. 3 feet is bed, 1 feet in the left side and 1 feet in the right side. And within this 5 feet, you have to accommodate minimum of 10 socket in a cardiothoracic.
You can go for vertical manifolds.
There also you will have the same location. It will be more closer than in a horizontal manner. Is there any other solution you recommend, sir?
No, what we are doing nowadays is we are having RCCB again for every bed, ICU beds. A separate RCCB, because we'll have number of sockets. Like, most of the fire incidents, whatever we have seen, especially in pediatric hospitals, incubators, where there are number of incubators where we're there. Every incubator needs almost, in a hospital, maybe around 6 to 7 power plugs. Some of them are on UPS, some other on raw power. So have a separate RCCB for everything, because most of these areas are monitored by the nurses all the time. So they can also, and then have, this is what we did for a hospital in Nigeria, where even this RCCB status is monitored from a central nursing station. If any tripping happens, then they will immediately come to know about it. But only thing is, they all should be on UPS and then try to avoid any kind of trippings. That's what our primary. Otherwise, you better, provide like NFPA 99 recommends, even ICCU should have isolated power supply systems. But for us, operation theaters itself, our people are not providing. We could not push to ICCUs. That's the thing.
Thank you, sir.
Thank you.
Thank you, sir. It was a very interesting session and very enlightening too. I would request Mr. KB Vinod Kumar to come up on the stage to give Mr. Srinivasan our appreciation memento.